Okay, so here we are once again. We're going to be on the 1.3, page 21. We're going to be talking about ordering real numbers. One thing I want you to recognize here is that when we get to this ordering real numbers, right, 1.3, you should be paying attention to the fact that this is the last section of chapter 1, which would be module 1 in this case. So, lesson 1.3 talks about different models, as always, and it talks about, in example 1, comparing the square root of 3 plus 5 compared to 3 plus the square root of 5. Now we can see that these are different, I'm hoping, because here the square root is 3 and here the square root is 5. So what we're going to really talk about is a little bit of approximation here for ordering these totals. We need to have an idea of what this is. And we need to have an idea of what this is. Alright, so when we say that, I know the square root of 3 is greater than 1 and less than 2. Right? Because the square root of 4 is 2 and the square root of 1 is 3. Right? And then we're going to add 5 to it. Alright? That's how we want to look at this comparison to make it as easy as possible to do this particular issue. Alright? So, hang on a sec, I've got something to get off of my screen here that I hope you didn't get to see. Alright, so this is our value. We're talking about estimating our value. So we're going to look over here and we're going to estimate our value as well. And this is 3 plus a value that is more than 2 and less than 3. Now, ideally, one way that we could look at this is we could look at this by simply looking at it and using a calculator and adding these two together. But what we should be able to see, and that's in accordance with the book, is that this one should be somewhere between 6 and 7. See if that makes sense to you, that it's going to be between 6 and 7. The other one on the other side of this is going to be between 5 and 8, 5 and 6. Now, see if that makes sense to you. Look, we know it's in between 2 and 3, right? So 3 plus 2 is 5. 3 plus 3 is 6. 5 and 6. So obviously, or what should become obvious to you, is that we already know this value is greater than this value. Simple? Alright, so that's a quick rundown on it. Now we're going to move on, and we're going to go to page 21, and we're going to spend a little time there. So, we're still in 1.3, page 22. Alright? This is not a really difficult thing to accomplish and to get correct most of the time. But you've got to be paying attention to what's going on. So, example 2 says order, and this is what you're going to see on many, many tests in your future. Square root of 22. If I could use a calculator, But I'm telling you, it's not that difficult. Four and 1/2 least to greatest. All right, so how are we going to accomplish this? The way we're going to accomplish this, I think, is first off to recognize that the square root of 22 is between 4 and 5. 4 times 4 is 16, less than 22. 5 times 5 is 25, greater than 22. Just like we did before. Now we're going to look at this value, which is pi. Some of you are going to look at pi and say, that's 3.14, because you did that in 7th grade. But let's say it here, pi equals 3.14, and that's not exactly true, because that number goes on forever and ever. And then we're going to add 1 to it, so 3.14 plus 1 equals 4.14. Clear enough? So this is between 4 and 5. This is 4.14, essentially, since that's the value we generally use for pi. Well, then we're going to look at it and we're going to see what happens for 4 1/2. Since we're thinking in decimals, at least at this point, 4 1/2, from my smart 7th graders and 6th graders who have worked with this, is around 4.5, right? It's exactly 4.5. So when we look at this on a number line, we have two values that are accurate. All right? This one, 4.414, we could say is right about there, assuming that this is the value of 5 on the number line. This one is exactly 4.5 on the number line. So we know that to be true. The one we're not sure of is 4 is the square root of 22. Sorry, square root of 22. So it's a good place for us to have a calculator. But I can tell you it is between, it's in the neighborhood of, and here's how we write approximately, 4.7. And you'll see that in the book, in your drawing. So, isn't it the greatest of the three? Okay, so we're moving along, because time is of the essence. When we look at example 3, example 3 talks about 4 people have found the distance in kilometers across a canyon using different methods. Their results are given in the table. Order the distances from the greatest to the least. If you're going to do that, you're going to pretty much evaluate, just like we did here, different values. So the values we're going to evaluate are the square root of 28, 23/4, 5.5 forever, and 5 1/2. What I can see immediately is true here is 5 1/2 has to be less than 5 5/10 forever. Remember we talked about that forever quality? So that's 5.555555555, it's got to be more than this. So this is greater than that. Now, if I'm going to place them greatest to least, as the instructions say, and you've got to pay attention to this factor, greatest to least, then I'm going to say 5.5 forever has to come somewhere between before 5.5. Now, that means I've got this one and this one, but it doesn't really mean I've got these, right? And I know a tool you can use to make sure that happens, and it's on your cell phone, and it's in the back of my room in a nice box that I built myself just for you, a calculator. Okay, so that takes us through pretty much what's going on here before you get to guided practice, and then do your independent practice on page 25 for turning. Thanks, guys.